Okay, so what we're talking about today, let's do a change of base problem. We haven't seen this problem since I think it would have been Monday or Tuesday this week. It would have been the first day we are in this section. I have 3 problems picked out. 3. Alright, so the first style of problem that I want to go over is a problem like this, where it's 25 x plus 3, and we have 125 on this side. This is going to be very similar to the first couple problems that you have, and I want to make sure that you know how to do it. Now, I will change this problem up a little bit so you can actually see what would happen on a different situation in this problem. This problem requires a change of base. There's an easy way to solve this one where you don't have to use logarithms for it, and that's what the first 4, I don't want you to try to use logarithms or those little shortcuts. This is what I like you to do. You're going to change the... Okay, we're going to change 25 to be 5 to the second. So we're going to change 25 to be 5 to the second. We're going to change 125 to be 5 to the third. Whoa. And then what we'll do is, now that we have the bases the same, we can set the powers equal to each other. The only thing is we have to deal with these powers here. These two get multiplied together. It's a power and a power. It's called the power rule for the law of exponents. So when you multiply that, you get 2x plus 6.
Well, you just scratch those 5s.
And we'll get to that here in a second. Alright, so I just simplified that power up here, that I combined these two where you multiply them. And now, you're actually right.
Multiply 5.
So the last step here is you would actually get rid of the bases, because the bases match, so the powers have to match. So this is 2x plus 6 equals 3, and then we can go ahead and we can solve from there. So you'll subtract this across, so 2x equals negative 3, and then you'll divide that over, okay? And we'll get negative 1.5. You actually divide. Now, you can leave it negative 1.5, you can leave it negative 3 halves. I almost prefer that you just leave the fraction state. In all the homework, maybe except for these first few, the first 2 or 3, I don't think you're going to need a calculator. I honestly don't. These first couple you could, if you don't know what power to put that number to. Let's say you didn't know how to change 125 to be like 5 to some power. So that might be the one reason why you would need to use a calculator. Okay. All right. Questions at all about the first style problem? We haven't seen one of these for a couple days. Everything we've been doing, yesterday and a little bit on Tuesday was always changing them so they have logarithms in them, and then you can get exact answers. But on this particular problem, you don't need to, because they have the same bases, or at least I can change them to be the same bases. Okay? Now, how this problem could be different. They could do something like this. I'm not going to make this do this problem. Again, if you just want to watch, you can do that. On this particular problem, if they change it to be something like this, if they change it to be something like that, you can move it around and you can change the power. So like, yeah, so I can put this as, I can make this a half power, because that's the radical, and then you can move it up and make it negative. So if you want, this is a way that you can change that problem. And then from here, you can go through the same steps as the problem that I just did. That you can change the bases to be 5s to powers, and then you can go from there. Okay, is there any questions with how you can move stuff around?
No.
Okay, remember, radicals, you can make them to half powers.
No, not in there.
Okay? Or thirds or fourths, depending on the radical. Alright, let's go to the next style problem. Okay? Alright. So, hey, too many conversations? Okay. So, next one. Alright, here we go. 5 to the 2x plus 5 to the x minus, I think it's minus, what is it, 12 equals 0. I think this is the problem that they use in the book.
We can't do that.
Okay.
Wrong.
This style of problem, you can factor it apart into pieces where you can, when I see this problem, this is what I think of. I think of this.
You think of factoring.
X squared plus x to the first minus 12 equals 0.
That's what I think.
And then you can do the normal factor from like element 2.
Log base 5?
Okay. Yeah, it's gonna have a base. So yes, we'll eventually change this problem. Okay, so this is the style of problem that I'm doing here. But instead of x's, we have 5s. Okay? So actually changing this problem up, here we go. Okay. Okay. 2 parentheses equals 0. We have the plus minus sign. Now on this one, I'm going to put 4 and 3 because I want to get a 1 in the middle. And it'll be a positive 1. And then for the 5s, I'm going to go 5 to the x, 5 to the x. Because if you actually multiply those together, you'll get x, 2x, which is x squared. Right? So, okay, questions on how I change this? I know that seems a little goofy.
How does that work with numbers?
With digits, it's the same thing. You just like put them as like x's. You can do like a substitution, and they can sum them back in. Yeah, it's kind of weird. Because yeah, a lot of people always like, well, doesn't the 5 affect the middle number?
Yeah.
It technically doesn't because they have x's on them, so you couldn't combine them anyway.
True. Alright.
So, all right. But each one of these parentheses is supposed to be equal to 0. One of these has to be 0. If you think about it, because if you multiply them together, they're equaling 0, so one of them has to be 0. So what you do is you set each of these to be 0, and you solve for each one separately and see which number actually works. So like on this particular problem, I'm going to subtract the 4 across. 5 to the x equals -4. This problem can't work. You can't put a 5 to a power and get a negative number. You can make it smaller, you can make it a fraction or a big number, but you can't make it
But what if it's a negative power?
no,
makes it a
negative powers
fraction.
just makes it fractions. Because so if like you did 2 to the -3. That the negative just means you put the 2 to the 3 on the bottom, and it's a fraction, it's still positive. So that one doesn't have a solution. But this one does, because if I move that 3 over, it becomes +3, and now we can do the whole thing where we change it back to a logarithm, where I can't change the base like the last problem, so you do the little circle method. Log base 5 of 3 equals x, and that's my answer. That's how you do it. Now, you do not need to type it in your calculator. I do not require that you give me the exact answer, or the decimal approximation, I should say. That's what I expect to see. Okay, questions, comments, concerns? Okay, good. Let's move on. Last problem of the day. This is one that I kind of promised you I want to go over today, where we're doing the properties of logarithms, where there could be logs on both sides, there could be just numbers with logarithms, but you're going to combine them down. I'm trying to show you kind of one of each type of problem you have today. A majority of the problems are kind of like this, where you change them back to logarithms, you get the exact answer. You need to look back at a lot of the notes we've done the last couple of days, because I've done a lot of the examples like actual homework problems. So, alright, I'm going to leave that up there. Last problem.
Do Monday.
Do Monday, yep.
That is so fast.
So, you got a couple days. Alright, here we go. Hi, Whip. Alright. Okay, alright, last one. Now, here's my question. Okay, do you want a problem with a number, or do you want a problem with only logarithms?
Only logarithm.
Okay, alright, here we go. Okay, alright, log x plus 7.
What number is this?
Number 82. Log x plus 7 minus log 3 equals log 7x plus 1. Alright. Now, this problem is, since we only have logarithms, we don't need to move them around. Like, if there was just one of the problems, like one of these items up here, one of the entries was a digit, just a number, like 7. Okay, like that was just 7. You'd have to move that 7 across and move all the logs to one side so that you can combine. But if there's only logarithms, you don't need to do that. You can keep them on their own respective side. You don't need to move anything around. You just want to combine these down so it's one single logarithm equals another single logarithm. Like that side is already one logarithm. I'm going to leave that alone.
Just make it division.
Okay, yeah, this part I'm going to make it division. So when we do this problem, and you combine this down to this, since they're subtracting the two logarithms, you're allowed to change this to one single log, and you divide the two parts. Because the subtraction means you actually divide the two entries. And then we have log 7x plus 1. Okay, are we good so far?
Yes, Mr.
Okay,
Moore.
now, since they have the same logarithm on both sides, I'm allowed to cancel them out. If there was a number on that side, you'd have to do like the circle method and bring it back, where like this base, which in our case is a 10, to that power equals this thing, but I don't need to do that. Since I have two logarithms on each side, I'm allowed to just cancel out the logarithms, because they have the same bases anyway. So I'm allowed to cancel that out. And so this is what I have. And now to solve.
Multiply by 3.
Yep, you multiply by 3 to the other side, so it gets rid of the fraction. So this turns out to be 21x plus 3. And then you'd actually solve. Okay? So, yep, so I would move these around. So if I subtracted this across, I'd get 20x. Subtract the 3 across to get 4. And so it looks like my x is going to turn out to be 1/5 if I divide by 20. And that's the exact answer. Now, you'd also have to, on some of these problems, they require that you plug the number back in to see if it works. What I always do just to check this, if you plug the 1/5 back in to where the x's are in the very beginning, and it doesn't make negative numbers, you're probably good. That's usually how it works.
Probably?
Yeah.
I guarantee
so,
that you're good.
If this turned out to be negative, like let's say that was a really large negative number and you plug them in, then you can't do that because you get really big negative numbers and you can't take a logarithm of a negative number, so you'd have to throw that answer out. For mine, it's a positive, so it's probably the right answer. Now if you want to check, you could always plug it in and see if both sides actually equal and type in your calculator, but I'm not going to require that as long as it doesn't turn out to be negative. But those are the types of examples that we have. Any questions on the 3 types today? No. Now, again, if you look back, I've done more types of examples for you over the last 2 days in here. Definitely look back at some of those examples. They are probably exact problems out of your book that I've been doing the last couple days.
Good thing I wrote them all
So-
down. Good thing I stored them up here.
Good, alright. Alright, here's your homework. Yeah, I'm going to make it due Monday, so you have a couple days to work on it. It's pretty straightforward. The only problem is, if you wait till Sunday night to attempt it, you could forget everything we've done. So don't wait till Sunday.
Mr. Ward, don't forget they're on MrWard.org. I saw that.
They are on there. Okay, alright. They are on. If I supposed to do that one. Alright, here we go. Homework today, and now, this is going to seem really big. I jumped around a lot, and some of these problems I've definitely done for you, so here you go. Okay, page 433. So, yep. Alright, page 433. Okay, numbers 14 through 20 evens. So those are going to be like the first ones I did today where you change the bases. You don't need to cut them unless you don't know how to change them. 31, 34, 39. Then I jump to 44. I jump to 58 through 62, the evens only. 72, 73, 78, and 81. Okay, so I kind of jumped around, and I know that seems like a lot. It's not, because I try to pick a couple of each style. So like these first couple, you can change the bases so they're the same number, and then you can just set the powers equal to each other. These here are just like single like exponential problems where you can change them back to a logarithm. These couple in the middle are where you have to factor. You have to factor. Some of these are where there's logs on both sides and you have to combine them down and actually solve for x. Always double check to see if the numbers don't give you negatives on the inside of the logarithms. If they do, then we have a problem. You can't do that. Those are undefined. But most of these should work out. I think I did an example yesterday in class where it didn't have an answer. Because of that situation, I was trying to kind of warn you of that. So just be cautious. Some of these, if you've been taking notes, I've definitely done them in class. It was that problem I did in class. So just, if you have notes, you're probably good. Okay, alright.
You dog.
Alright, there you go. Rest time is yours.
Now we have to erase the board. Come on. Oh, yeah. How did you give me this?
I'll get this. I don't know if I want to do this.
You do. I don't know what I want to do. Every